Hi gang, I'm going to make a little video of the spring review problems this morning here. And this is the best review to know. Here are all the formulas that you're going to get on the final. Okay, the first one, the median is the best measure of center. I mean, we really have two choices, the mean or the median. The mean wouldn't be great because of that 200-foot tree would really mess up the average. So we want to go with the median. So anytime you have outliers, the median is going to be a better measure of center. Okay, what you have to do on this is you have to find the average, or it's called the mean, same thing, with all the data. So you get 141 over 8, which is 17.625. And then take out the outlier and recalculate the average, and it turns out to be 13. And you figure out what the difference is between those two. And you can tell that's 4.625. And that means that that 50, that big number, that outlier, increases the mean by that much. It increases the average by 4.625. What percent of the data is used that's between 20 and 70? You can tell that it's a whisker, this little whisker right here, plus the box itself. The box itself is always 50% of the data, plus 25% of the whisker, so that's 75% total. The one that's incorrect is C, because it's actually supposed to be 75% of the data that's greater than 46.5, because it's again the box and it's a whisker. All the rest of them are correct. This one's skewed right. It's kind of unbalanced to the right, a little more spread out to the right. This is higher standard deviation is Miss Jones' class. You can tell she has a really low score of 62, looks like is her lowest. Remember how it starts in the middle here. So 62, and then she has a high score of 100. It goes 10 and then use the leaf. Miss Carson's class isn't quite as spread out, so you can tell. And then you should also check the medians. So I checked the medians of each of those, and it looks like the median is actually higher in Mr. Carson's class, so that's why that B answer is incorrect. Alright. This one, when you look at it, you can tell that it is a geometric sequence, and you take one of the numbers and divide by the one right before it. So 18 divided by -6 is -3. That's your common ratio, and so you just plug it into your geometric formula, explicit formula. So you put your starting term, your first term 2, and then times your r, and then raise it to the n minus 1. And then just use your calculator. This one's arithmetic. You can tell that you just have to add to get to the next number, add or subtract. In this case, you just have to add 4, so that's your common difference, and use the arithmetic formula. You just need to put your first term there, and then we're looking for the 20th. So 20 minus 1 times the 4 gives you 72. On this one, we have the first term is 5, because you just count up the squares. The second term is 9, and the third term is 13. You can tell that when you go from 5 to 9, you have to add 4. So when you write this recursively, your first term you have to list, so that's a sub 1 equals 5. And then this notation says that whenever you're looking for a particular term, you have to use the term that's right before it. So that's why it has less. This is a sub n plus 1, and this only has a sub n, so it's the one right before it. And you have to add 4. So that's how we define it recursively. For this, I would say try to figure out what your ordered pairs are. So you can see your ordered pairs are 1, 7, 2, 15, 3, 23, and then of course 4, 4, 31. And then just plug the numbers into each of those functions and see which one actually works. So when you put a 1 in there, that would be 8 times 1 minus 1, which would turn out to be 7, which would satisfy the equation, satisfy the function. And then if you put a 2 in there, that would be 8 times 2, 16, 16 minus 1, that would be 15. So that's the only one that satisfies, that's satisfied by the ordered pairs. 62, you can tell the way this is written recursively that the common ratio is 4. So then just look for which one of these would be a geometric sequence that starts off at 3 and then has a common ratio of 4. And it's B. We're using our compound interest for this one, so we start off with 15,000. The formula is given on the front. 1 plus whatever the rate is. Usually you have to divide that by n, the number of times it's compounded annually. This time it's only compounded once per year, so we just actually divide that by a 1. And then this would have been t times the 1 as well. And so it doesn't really affect anything. So then you just try some of these years, and the only one that works is the 20, and then we'll have enough money. Then we'll have at least 30,000. 64, you want to take the square root of 64 first, so that gives you 8 square root of x to the 5th. If this doesn't have a number up there, that's understood that it's a square root. So the index, that's what the number's called. It's called an index. It's an index of 2. And then you just have to remember how to write a radical and turn it into a fractional exponent. So the 2 goes on the bottom and the 5 goes on the top. Same thing for this one. You're just changing it from the fraction form to the radical. So just the reverse. Exponential functions have the variable as the exponent, and then you have to make sure that you're multiplying by a number that's bigger than 1 for it to grow. If it's less than 1, then it's exponential decay. Anything that has a percentage like this, these are all exponential growth of some sort. Doubling is exponential growth, so if you have something that grows by a constant amount every single year or day, then it's going to be linear. So C is the answer for that one. Anything that triples is exponential growth, so you should be looking for a graph that grows exponentially and that starts with 4, so D. This one triples, so we know it's an exponential function. We can see that that would be a 3, and then it has to start off with 15. So B is the correct function. Exponential functions, we're looking for something that you have to multiply by to get the next number. So this one you have to multiply by 4. All these other ones are growing by a constant amount. Except for this one's a little strange. It goes up and then it goes back down. So this one's probably a quadratic. So this one's very linear. 71, you want to do some distributing. So you distribute really well. You want to make sure that you distribute the negative sign as well. So negative times a negative gives you that plus 6b, and then combine like terms. When you're adding and subtracting like terms, you don't touch the variables at all. You're just carrying them along for the ride. I would recommend doing a box on this one. So 2x minus 5, just put it off to the left, and then your x cubed plus 2x minus 1, you can just put that right above, and then just multiply them together to fill the box, and then combine your like terms. This one, you won't miss it if you take the time to rewrite x minus 3 side by side, and then we say we distribute, which is FOIL. So x times x would be x squared. The outside would be minus 3x. The inside would be minus 3x. And then negative 3 times negative 3 will give you the positive 9. And then we can combine the two middle terms. We want to factor completely, so we want to take out the GCF first. So the GCF is 2x, and then we put parentheses and we see what's left. There would be an x squared minus 49 left, and then we'll do a double bubble. That'd be x minus 7 times x plus 7. That would be that answer. Whenever you have a square root, you want to take, or when you have a squared, you want to get rid of it. So you square root both sides. Gives you 4x plus 1. And then on the right, it's plus and minus 1. And then you have to do two separate little equations. So 4x plus 1 equals the positive 1. And 4x plus 1 equals the negative 1. And then just solve for x. So we get two different answers, 0 and negative 1/2. This one you want to do, I wonder where the work went for this one. Hold on a second. Oh, there it is. So you want to do a double bubble. You want to look for two numbers that multiply to be negative 12 and add up to be negative 1. It's negative 4 and 3. And you can go right to your double bubble and then set each of those factors equal to 0 and get your answers. This one's the same as the other one. When you have squared, you want to take the square root. So we take the square root, and we get x plus 3 equals plus and minus the square root of 7. And then write x plus 3 equals 7, x plus 3 equals negative 7, and solve for each of those. Subtract 3, and then subtract 3 from each side. This is the quadratic formula, so make sure you identify what your A, B, and your C are before you start, and then just plug it into the quadratic formula. So you can see all the work there. Negative B, so the opposite of B, plus and minus the square root of B squared, so that's negative 7 squared, minus 4 times A times C, all that's divided by 2 times A. So 7 plus and minus, 49 minus 8, so that'll give you 41 under the radical, and then that's really all you can do because it's not a perfect square. The roots are wherever it crosses the x-axis, so it crosses right there at negative 1 and 3. The correct choice for this, you'd have to look and see. The transformation is to the right 1 unit, and then it's up 4 units. So normally the graph of this looks just right here at the origin. The parent graph is f of x equals x squared. But this one's different, so it should be to the right and up 4, and also flipped upside down, so reflected over the x-axis. This is our negative b over 2a formula. So when you do that, you get negative 2 for the negative b over 2a. That's your axis of symmetry. This is your axis of symmetry. And then you have to take that negative 2 and plug it in for all the x's, and you get 2. So negative 2, 2 is your vertex. And your axis of symmetry. And it looks like we have the same answer there twice, so it's A and C. Sorry about that. The maximum height is going to be wherever the vertex is of the parabola. So we're going to do negative b over 2 times the a. When you do that, you get 1 second, and then if you want to actually figure out what the maximum height is, you have to plug it in. So we take a 1 and we plug it in for all of the x's, and we get 16 feet. We're looking for a pattern on this one. It looks like it goes up by 6, and then plus 18, plus 30, plus 42. So it's not really, you can't really multiply by something to get the next number, and you can't add the same amount, so it's not linear and it's not exponential. This one actually turns out to be quadratic, and the function that actually works for this function is 6x squared. You can try it. If you plug in a 1, it'll give you 6. If you plug in a 2, it'll give you 24, etc. So it does work. What kind of transformation is taking place from this parent graph to this one? Well, there's a 7 on the outside, so that's vertically vertically stretched. And then plus 9, it's shifted up 9 units. We have to solve this system. It's by substitution. So x squared minus 6, we substitute it in for the y in the other equation, and then we slide everything to one side and set it equal to 0. So we do our double bubble, look for your numbers that work. You can tell negative 6 and 2 work, and so you can say your answers are x equals 6 and negative 2, and then just plug those in. The best spot is that one right there. So plug both of those x values in to get the y values to go with it. And this one is just a shift from the normal parent graph. It's a shift to the left 1 unit, so it would have been just right there at the origin, but you can tell it shifted just 1 unit to the left. Which one grows the most? The functions that grow the fastest are the exponential functions, meaning that whenever you plug in big numbers for x, the y values get really, really big, really fast. All these other ones, they grow, but they don't grow as fast as the exponential functions. This one, when you plug in a number that is 0, x is greater than 0, it's 3, so it's that one. That should be actually an open circle, so it's hard to see, but it should be like that. And then whenever x is less than or equal to 0, it behaves like a parabola, but it's a parabola that is shifted down 1 unit. So you can tell it starts right there. So you can plug in some points, you can plug in 0, and you can tell that that's negative 1. And then again, anything that's less than 0 is gonna be a parabola shape. Last one. This is the absolute value function, so we know the normal parent graph is just right here at the origin, but this one's shifted to the right 2 units and up 4 units, so that's why this one makes sense. So let me erase that. So you can tell it's shifted over to 2 and 4 as kind of that starting point right there at the middle. Oops. And then that is it. I thought I had a the end. No, I don't have a the end. Okay, the end. Good luck. See me if I can help you individually, okay? Good luck.